All right, we are doing the Leak Code daily problem. It is 3487. It's easy, so let's take a look at this. But there was a 21% acceptance rate, 27% I think actually, and so we'll just have to be a little more we're going to be careful, I guess. It's going to be something. So you're given an integer array of nums, okay, and you're allowed to delete any number of elements of nums without making it empty. After performing deletion, select the subarray of nums such that all elements are unique. All elements in the subarray is maximized. The sum of the elements. All the elements in the subarray are unique. The sum of the elements in the subarray is maximized. So you will just want to include one of all of them, right? Is it just the sum of the... So, wait. Um, if we have a counter that gets the frequency of gets all the unique values, so um, that gets all unique, gets the frequency of all the unique values. But if we did keys here, it gets the unique keys, and then if we just converted that to a list and then took the sum of that, is that really the whole solution here? Return. This might be a really easy problem today. No, isn't. I'm missing something here. Okay. You can delete -1, -2. Oh, you don't want to include negative values. That makes a ton of sense. Yeah, that was where I was confused why that bullet point was necessary, but um, let's see if I just want to check something. Can you delete this list value here, or do you need that? Um, so essentially, you want to find all the unique values, and you could do that by doing these keys. Yeah, you don't need that list thing. Okay, so then if we just do a map of x, or not a map, a filter essentially of lambda x, where x is greater than 0. And the list is here, so we're just filtering on values that are greater than 0, or yeah, greater than equal to, doesn't matter. And yeah, I think that was a pretty easy solution today. um I see. Yeah, okay. Well, we're not there fully yet. If Yeah, it's not exactly that actually, because it can't be empty, which is kind of annoying. Okay, without making it empty, that's the distinction there. Okay, that's fine. We're just gonna have to do this a little bit differently. Okay. um Values, so we have values here, and if so highest is going to equal um, so essentially what we have to keep track of is the highest value, and we're going to have to remember that if all the values are negative. So uh, yeah, this is better. We could have optimized it, whatever. We're just going to do this in a for loop. I for val and values, if val is greater than 0. We'll actually just first take the max in this. Highest equals max of highest and val. So we're always getting the highest value. So if value is greater than 0, that means that we want to add it to total sum. All right. And we know these values are unique because we did the keys thing here. Which is a little interesting, actually. This is not going to be right either. So the distinction here is if... Huh. Wait, if total sum is... If total sum is 0 or... No, it's not exactly true. It should be... It's a little funky problem. Okay, we want to use highest when... Ugh, I'm gonna have to do this. I don't love this, but... So this is to check... Yeah, I don't like that. So this is to check that if not total sum... So if total sum, return total sum, else this will return the highest value. So we're just kind of putting an edge case here to say, hey, if total sum has never been entered, so essentially if there's no value ever greater than 0, we should take the highest negative value. Yeah, now we're passing those cases. And now we pass all solutions. Let's see if we can optimize this a little bit. This is very, very sloppy. I almost want to go back to my original kind of solution where I had... That was 7 minutes. Okay. I just want to see if we went back to this where we did values. Okay, it's going to be a little bit slower, but I think it'll be more cleaner. Or summed, which is going to equal to, we'll just put it like that, summed, which is going to equal to filter. We're actually going to have a filtered, which is going to equal that, and yeah, this is going to make more sense, I think. Okay, and then, so essentially here we will do the filtering over the values, and then if the len of filtered, or if we could actually just do filtered here, which checks, Pythonically, it just checks if it's empty or not. We can check if it's empty, and then that means that we can just get the max values, and then else we could just get the sum of filter. So it's essentially saying, hey, if we have no values greater than 0, just return the max of the values, or if we do have that, we will just return the sum. And I think that keeps everything... I don't think that increases time complexity at all. Oof, wait, where are we messing up here? Sorry, this is if not filtered. We have this backwards. Okay. Yeah, and so that's a better solution. And we're back with this case. Not filtered. Max of values. Oh, does this need to be like list? Like, is it not? Yeah, okay, I just need to convert to a list because that doesn't actually check the list. Okay, perfect. Yep, so that's my solution. And yeah, and we can remove this actually. Yeah, great. Thank you for watching, everybody. Stay strong.